We're going to continue our discussion on the Limewater reaction. This is the same guided note sheet as before, so go ahead and pull it up out of Notability, give us a split screen, and here we go. Our focus question for this lesson is, what happens at the particle level during a chemical reaction? So we know we end up with something new. We know that because there's a color change, combustion, there could be a gas being created, etc. But what happens to all those little atoms and compounds in a chemical reaction? That is the focus question, and that's what we'll be looking at. Okay, I want to be a little bit more specific with this question. Not pumping just air, but what happens when we pump CO2 gas into lime water? CO2 gas. So if you'll recall, we had a little jar of lime water, mostly clear. The lady blew CO2 gas into the water and white substance began to form and fall to the bottom. After 5 minutes, there was a large layer of white milky substance on the bottom. What was that substance? It wasn't there before, and it was a result of a chemical reaction. So I want to look at what happens when I pump CO2 to lime water. A new vocabulary word for us. The milky white substance is called a precipitate. A precipitate is a new substance and it is evidence of a chemical reaction. The definition is that it is a solid substance that will not dissolve in water. So I could not take the new substance from the bottom, mix it up with pure water, and think that it would dissolve. It will not. It'll fall straight to the bottom. So consider these questions on your note sheet. What happened when I exhaled CO2 breath into lime water? Answer the questions on your guided sheet. Pause this video, and when you have finished, move on. So what is lime water? You know, I've heard of limestone. A lot of Kansas is lying on a bedrock of limestone. Lime water is a lot of the same minerals that is in limestone. It is made of calcium hydroxide, which is calcium, oxygen, and hydrogen. 3 different atoms in the molecule. But you'll notice some parentheses. And in math, if there are parentheses around numbers with a small 2 on the outside, that means I must multiply what is in the parentheses by 2. So it's not just one calcium, oxygen, and hydrogen. It is an extra oxygen and an extra hydrogen. And of course, these are not free-flowing atoms around the universe. To be lime water and to be a compound, the calcium, the 2 oxygens, and hydrogens must be bonded. So I can show bonding through lines like this. This is one compound, one molecule of calcium hydroxide that was dissolved in water. It was the clear liquid we started with without adding CO2 gas into the liquid. So this is what calcium hydroxide looks like. So you'll recall our beginning question as what happens to the atoms when a chemical reaction is occurring? What happens to all those compounds? We first have to give the starting atoms and compounds a name and the ending compounds and atoms a name. Whatever I start with is called a reactant, and whatever I end with is called a product. So our reactants in the lime water reaction were calcium hydroxide, just showed you how to create that, plus CO2 gas. And the products, well, it was something that was white and fell to the bottom. Not sure what it is yet, but I do know I didn't have it when I started. Notice that the arrow goes in one direction and not in both. When there's a chemical reaction, we create a formula, much like in math, and we create an equation. And there are certain rules for writing the equation. I have to add my reactants with a plus sign, like in math, and my reactants have to be on the left side. My products will be added together on the right side of the arrow, again separated by a plus sign. And I could have 3, 4 reactants and 3, 4 products. In this case, I'm only going to have 2 on each side. Again, the arrow means yield, and it does not mean the same as equal. As I mentioned, the yield sign is an arrow pointing to the right, one direction, does not go backwards. It is not the same as in a mathematical equation where you would write an equal sign. An equal sign implies that the left and the right side are the same. I could do the math in both directions. And in chemistry, in a chemical reaction, I cannot go backwards. So an arrow is a yield sign. In this case, I had little particles fall to the bottom. One of my products fell out of solution. I can show that by showing that an arrow is pointing down. The precipitate fell down. So my question to you is, what would the sign be for a gas? If precipitates fall down, what does a gas do? Here's an example of a chemical reaction. Notice my yield sign. That's how I know it's a chemical reaction in the middle. I have 2 reactants, reactant 1, reactant 2, and I have 2 products, 1, 2. There's that down arrow again. The down arrow indicates that I have made a precipitate, something that has fallen out of solution. And I asked you earlier, what sign do you think represents a gas, like in the fizzing reactions, when I added 2 white substances and got a gas? In the example, it's the up arrow. So all of our fizzing equations looked kind of like this. White powder plus white powder equals a gas, fizzer, and then something that dried up and was left in the well. Remember, ascorbic acid was yellow, and all the things that had citric acid was a white crystal left out. All fell out of solution, plus gas, fizzing with an up arrow. Calcium carbonate. So when we break this all down, the Limewater reaction, we can think of it in a few different ways. We could think of it in chemical formulas like this. CaOH2 plus CO2 gas yields CaCO3 plus water. H2O, excuse me, should say the formula. CaOH2 plus CO2 yields CaCO3 plus H2O. Well, what are these things called? Well, the left side, the reactant side, is called calcium hydroxide. AKA lime water, its common name. The other reactant is called carbon dioxide. And I add them together. That yields calcium carbonate, AKA, can you guess what fell to the bottom? Chalk. Chalk fell to the bottom. Plus H2O, also known as water. So I have 2 reactants and 2 products, and I made chalk with this chemical reaction. And chalk was one of our white substances when we did the mystery mixture. So that's pretty cool. We came up with one of the white substances that we needed in all the fizzing. But back to our original question, what happens at the chemical level with all these little elements and atoms, what happens to them once I have fizzing or burning or combustion or color change? So right here I have with me a colorful chemical formula. It's the same as the one we just erased. Calcium hydroxide on the left plus CO2 gas, yielding water and chalk. But I wanted to show you what each of the little atoms, where each one of those atoms goes in a chemical reaction. So you'll recall from before that I have compounds bonded together, and I showed that with lines. This bonding, I'm showing that they're together by just touching their atoms together. So they're bonded in pairs. But once a chemical reaction is started, those bonds are broken to create new substances within the solution. For example, this hydrogen here will now become part of water. And this oxygen here will also become part of water on the product side. And this calcium, number 3 atom, will come be part of chalk now, no longer part of lime water. I think you get the idea. This oxygen will also become part of chalk. This hydrogen, part of water. This oxygen, here. This carbon, here. This oxygen, here. So all the bonds of the reactants now become part of new bonds in the products, and I've created something I cannot go back. I cannot go back on my yield sign. I've created something new. So this is not an equal sign. I also want you to notice that every single atom that was on the left has been used on the right. Nothing has been lost. Nothing has been gained because matter is conserved. Matter is anything that takes up space and has volume. And what I started with, I end with, just making new substances by recombining. You can think of it as like 2 words on the left that I rearranged the letters for to make 2 brand new words on the right. Chemical reactions conserve atoms. Nothing is gained, nothing is lost. In this lesson, we introduced you to a few new vocabulary words. We are not going to put the vocabulary words in an index. We are going to instead use our chem strategy that we have used before on these guided notes to add 4 new vocabulary words. They are burning, precipitate, remember that's what fell out of solution, product, and reactant. Please pause the video. Please go to your chem section of these guided notes, add the term, the definition, and a reminding picture. Great job!